All right, so this presentation is a brief 10 minutes or so just to introduce the afternoon and the rest of the presentations. We heard a lot about the business aspects and the market aspects of multimedia and mobile devices. And this afternoon is about what it takes to bring these systems together and make solutions in the direction of what the business and the market want. So, first of all, by now you know who ARC is. We provide configurable IP for building silicon devices and multimedia systems. And you can see a variety of solutions built around our technology. It could be the chips from the semiconductor players, or it could be systems who have internal chip development teams building out components of those systems. And we have about 140 licensees of the technology building such devices. So what makes this happen is a platform. Okay, so the platform has multiple components, and Carl mentioned this earlier in the day today. So at the bottom, we have the hardware IP elements. These are the 32-bit processors, 16-bit processors, SIMD engines, various hardware logic blocks, such as motion estimation, entropy encode and decode, etc., various connectors to connect things together. And these hardware IP elements get put together into silicon devices and pressed out into these chips by various customers of ARC. Layered on top of these hardware IP components are development tools, and there's a wide range of them, right from compilers, debuggers, profilers, to system-level modelers and simulators at various speed levels and various level of detail that they expose to the developer. And also various runtime operating systems and runtime executives for the devices when they're actually created. And on top of these, we have a suite of application building blocks. These are pre-verified solutions, such as video encode and decode at various resolutions, similarly for image and audio, and various application elements that come together on these development tools and hardware IP to create solutions. And all of this is wrapped in a platform that makes it easy to use all these different components and also to explore different architecture choices and actually do it very rapidly, so you address your time to market issues and try to get to much better systems very rapidly. So there are many fundamental issues that people have to contend with when designing silicon devices and systems, the kinds of which we saw this morning and during the lunch hour. Performance is critically important. When you go from SD to HD using the same kind of technology, you need to move up to something like 18 gigahertz of processing, which is impossible to do. You need to do it all in 200 megahertz or 300 megahertz. So what kind of solutions do you need? You need heterogeneous, multi-core RISC plus SIMD plus hardware logic kind of architectures. So there'll be a talk going through what kind of solutions we are creating in this kind of space. Power is clearly another very important fundamental, and we saw the talk from Cadence and various other components earlier today. So energy-aware computing with power domains, voltage domains, frequency domains, etc., and how to make the operating system and the application aware of these capabilities and modulate the use of power in the silicon device. Size was another key consideration, and with ARC's configurable IP cores, you can configure and tune the resources that are being used for the particular application in a very fine manner to have control over the size of the solution you're building. The scale is another very important factor. From the same design or from the same system concept, can you create multiple products? One high end, a mid range, and then a low end. Or can you add new features, or can you add different resolutions, etc.? And this all comes down to scale. Can I kind of replicate the design to make more of it or less of it or something like that? And all this comes with a lot of complexity. How do you address the complexity in the development of such systems? And you need multiple tools, each of which is best in its own class, but all of them need to work together. And in fact, you need to get much better visibility into the entire system that you're building. And so we will have some discussion on how do you get visibility into a system that is partly in hardware logic and partly processor, partly software, with operating system applications, etc. Then there is a very rapid evolution both of standards as well as features of the products in the market. So how do you address that? And software programmability is a key component of that. So a whole system, software, the middleware layers, and the hardware IP has to be designed together. And finally, time to market. One of the elements of doing that is using pre-verified solution components that can be combined into system-level solutions very easily. And so we are going to discuss all of these issues and what are the technical underpinnings of these solutions throughout the rest of the afternoon. So this afternoon, what we have is we're not going to talk about specific products from ARC or specific products from anywhere else. We're not going to talk about selling something. This is really glimpse into technology still under development and active research areas that the various CTO group members are driving within ARC. The next talk is about multimedia solutions. How do we get from SD to HD? That will be by Dr. Eugene Metlitsky. And as a summary, the key messages here are, what does it mean to do HD encoding with high quality? And especially when the standards and features, etc., are evolving. And what does it mean for system design to respond to these kinds of requirements? And the next talk will be on the multi-core architectures that ARC has come out with. And so Dr. Nigel Topham, who's also in the CTO group, he's not here today. Karlek Wong will be presenting this talk. And he will show how heterogeneous multi-core architectures are being used in ARC solutions and what are the engineering trade-offs that we have to make with respect to power, frequency, area, performance, etc. The next talk, there will be two speakers here for an extended talk, Dr. David Greaves and Dr. Tom Panello, both from the CTO group. They'll talk about the various system development tools. How do you tame the complexity that arises in these very large, full-featured kinds of systems? And in particular, how do you get visibility into the full system that you're designing? And finally, I'll be back here talking about how to wrap all this up into a platform that can rapidly iterate through the design space and make recommendations on architecture choices. And also, how do you get order of magnitude improvements in the engineering characteristics of your solutions, as opposed to 10% here or 20% there? Okay, so that's how the rest of the afternoon will go. Lee?